Good morning, good afternoon, good evening. It's me again, Professor Fleming here with the third in a 7-part lecture series on perspectives on energy and environment, and the course's principles and methodologies for sustainable design. Last week we looked at renewable stocks of energy like biomass and food. This week we're going to look at non-renewable stocks of energy like fossil fuels. Just as a review, natural resources exist in 3 forms: renewable stocks such as forest, food, water, and some worry that these renewable stocks can't be replenished enough to satisfy growing human population. Today we're going to be looking at non-renewable stocks, fossil fuels, uranium, etc., and some worry that even with technological advancement and new discoveries, we will either run out or the damage will be so intense that future generations can't survive. And next lecture we're going to be looking at the flows of energy, wind, solar, radiation, etc., and some worry that the cost to deploy those types of energy is too high in today's market-driven economy. And specifically this week we're going to look at coal, oil, natural gas, and nuclear. Starting off with coal, some of the basic facts that you should know are that the units for coal are short tons. The power that comes out of coal or is used or is created when you burn coal is BTUs. And that'll be important later for sustainable design when we get into energy use intensity, which is BTUs per square foot. The efficiency of coal when it's burned is only 31%. Profits are very high, although starting to go lower. Many externalities in coal: acid rain, CO2, nitrous oxide, etc. And lots of coal left, plenty of reserves, and certainly more opportunity to use the material more efficiently. Coal is in sedimentary rock composed mostly of carbon and hydrocarbons. It's one of the most abundant fossil fuels produced in the world. And it is a non-renewable energy source because it does take millions of years to create. And the energy in coal comes from energy stored by plants that lived hundreds of millions of years ago. So you're really still burning solar energy. It just happens to be solar energy that was here a million years ago or so. Some of the externalities with coal, we worry about acid rain, for example, which ends up killing fish in lakes, and we certainly worry about carbon dioxide emissions from coal. According to this, 1/3 of total carbon dioxide emitted from all U.S. fuel sources. So we know this is a major issue. And we also have problems with fly ash and slag in terms of where to store that waste, because it does have radioactive content and other toxicities. And certainly we see when we look at strip mining, which is taking the top of a mountain off, we're seeing the waste or the waste from that process being dumped in creeks and streams at the top of mountains. When we think of reserves in coal, though, we think of the fact that coal is only 31% efficiency, making the idea that we can get more energy out of the coal itself possible with better technology. And certainly we can find plenty more coal. From an experience perspective, however, the burning of coal has tremendous impact on people's daily lives. So this is in Shanghai, and because the air has become so polluted in China in these major cities from burning coal, they had to create these giant video monitors to recreate the experience of sunrise or recreate the view of a clear sky. So when we think of coal, we think of big comfort. In other words, we're trading those kinds of loss of experiences for more comfort in our daily lives. And we have to admit, though, as much as we might dislike what coal has done and really be upset about it, it has raised the quality of life of millions of people around the world. Not all, but for many of people, and that then forces or moves cultural evolution forward. So for example, I'm making this video right now, and probably some percentage of the electricity that we use in Philadelphia is coming from coal, although we are high on nuclear here. So what do we do here? We want to increase comfort and convenience, but we also know that coal is extremely damaging, and this is why sustainable design is so important. So from experience perspective, that really sums it up. From a systems perspective, there's a couple different major ways to get coal. Deep mining is one of those ways, and you see here a drawing of how that works as a system. But coal is generally a very centralized system where the coal itself has to be processed in a central plant, and the infrastructure to support the coal industry is very, very high and very complex. And I would call this an open loop system in the fact that many of the externalities are not accounted for. And later when we get into renewable technologies, you'll see that the externalities are very low. And the ecosystem risks are very high. In other words, the potential damage to the system or making the system unstable are very high with the use of coal. And however, though, coal, once it starts burning, is actually relatively efficient in the sense that it's hard to actually stop it from burning once it starts. So it can generate a lot of power and a lot of electricity once it gets going, which also means that you really can't stop or start a coal burn very easily. And that will play out later when we talk about coupled systems in sustainable design. As I said before, strip mining is one of the ways that we get coal, and this is what happens to the top of a mountain. Usually these are in rural areas that we don't generally see, but as a system, it's a pretty destructive system. It is now used to produce most of the coal in the U.S., and it is less expensive than underground mining. And some wonder if it's an ethical process, but certainly it's safer than deep mining. So then, if you have to ask the question, if you're going to have coal, which is better, continue deep mining or do strip mining? And so here's a couple of the other externalities that come in the systems of coal. There's a huge waste of slurry, fly ash and slag that's radioactive, and these levees have been known to break in the past, creating environmental destruction in its wake. And certainly when we look at it from a culture and society perspective, from a worldview perspective, we think of this as an industrial worldview energy source, which is now, we're no longer in the industrial worldview. So some of the societal benefits are incredible technological progress and process to allow greater levels of comfort and evolution for society. And the societal costs are pretty high. Lots of loss of life all over the world. In China, Chile, U.S., we're seeing coal mine explosions where people are being hurt. Rampant illness among coal mine workers and those that live near coal mines from pollution. And we have a history of worker exploitation, at least in this country and probably in other countries, that is pretty shameful. And also the other problem with these systems of coal, it requires lots of chemicals to support that process. And when those chemicals leak, they can sometimes leak into the water table and or water systems of a neighborhood or a region. So this was a recent spill of coal mine chemicals that went into a local river in the U.S. And certainly there's a human factor at play when we think of a coal mine explosion. These are real people with real lives who end up dead because of that experience. And so 29 out of 31 miners were killed at the Massey coal mine explosion in 2010. And you could say, is 29 people a lot, given the amount of energy that coal generates? And that really is up to each individual person's ethics. We do see, however, the movement in the world is to try to move away from coal for all of the reasons that I laid out here today. But it'll be many years before coal is outside of our system. So in order to have a summation here, coal has led to unprecedented improvement in quality of life for millions. It is a horrible substance from an experience point of view and from the process, something that most people would not want to experience. Some of the facts: it is probably the most damaging energy substance available over the long term that we can use. It's very low efficient when it burns, and it's not suited well to quick startup and shut down. In other words, not good as a backup for renewable energy, which we'll talk about later in the next lecture. And particulate matter, PM 2.5, is particulate matter that's so small that it can get into your lungs and create widespread disease. And we're seeing that in China now with a dramatic rise in respiratory illness. From a culture society point of view, it's an outdated energy source, but it has created unbelievable benefits for society, but also great price to pay for that energy source. From a systems point of view, open loop, extremely damaging to ecosystems. And so as sustainable designers, we can begin to pursue projects that use significantly less or no energy or no fossil fuel energy in our projects. And this is why carbon neutrality is one of the great movements in sustainable design, because it starts to look at not just the energy use, but the amount of carbon that you're reducing, which can then be thinking about future generations and their quality of life. And we can also not only just think of design, but we can also think of the processes by which our clients make decisions and the types of decisions they make. So purchase of Green E certified energy can be one of the strategies that one might use to help a client move towards zero carbon or certainly zero coal movement forward.